Let's wait for a couple of more minutes, then we can start. Can you see my screen? Muthukumar, can you see my screen?
Yes.
Okay, thank you. Okay, so we can start now. So the number of participants are decreased exponentially in this course. So let's see. So when is your exam for this course?
Excuse me.
When is your exam for this course?
March 26th.
Okay, so after this only one interaction session, right?
Yes, because March 26 means normally they will complete just 1 week before that.
Okay, so means the after this only one interaction session on
Yes,
19th.
yes.
Yeah, so let's see. So today I will solve the last assignment, last practice assignment, 8th practice assignment. And then we will do some previous year assignment question if time permits. So let's start. So let me ask you, is this interaction session helping you or not? You are getting something from here or not?
Pardon?
Is this interaction session helping you or not, miss?
Yes,
Like,
it's helping us. It's very much helping us.
okay, so let's start. Because the number of participants are decreased exponentially, so that's what I am thinking.
Because the time is Sunday, that too 7 to 9.
Okay.
That may be the reason.
Okay. So let's see the first question. Choose all correct statements. Tell me. So there is a field of order 1729. So is this statement correct or not? So what do you know about finite fields? What are the finite fields? Do you have any idea?
Order of a finite field must be of the form P power n.
Okay.
The P is a prime number and n is a positive integer.
So let me ask you more basic.
Pardon?
Okay. So Z mod PZ is a field, right?
Yes.
Okay. So now you
Well,
are saying any p to the power for any p to the power r, you can give me a field of that card that size. So suppose 2 square, that is 4. So give me a field of size 4.
1729.
Did you get my question or not?
You were asking whether 1729
Yeah, this
can
is
be
the question,
expressed.
but I am asking you more basic. You told that uh, any finite field has size p to the power r. So I am asking you that suppose take the number 4. This is 2 square. So give me a field of size 4. That is 2 square, because you claimed that every p to the power r number you can give me a field, right?
Yes.
Of that size. So how you will give?
No. For every prime number p and positive integer n, there is a field. Not
Of
that
size.
every field is of this size.
Okay, this is
So as
okay.
you said,
Okay,
Z4 consists of 4 elements, which is 2 squared, but which is not a field.
Okay, what Muthukumar saying, let me write here. Tell me your statement, what you are saying. Because you are wrong, that's why I am writing, so that I can correct. So tell me what you are saying.
Every finite field is of order p power n.
Finite.
Every finite field is of order p raised to the power n.
Okay, and what is
P.
not true you are saying? So is converts true any right?
Okay, if a converts not true, as you said, z by mod 4z, which is
Question is this question you are saying this is not true, that is
okay.
for every prime p and any natural number
n.
n, there is a field of
Order to p power n.
size p to the power n, order p to the power. So you are saying this is not true, right?
This is not true because you said that z by 4 mod 4z, right?
Yeah.
Consisting of 4 elements, which is
This Z mod 4Z is a ring, but how you are, this is only a candidate, how you are claiming? There may be other possible candidate, right?
Now
This is a
here we are
candidate
telling
of
for
4 size.
every prime and every natural number, there exists a field of order
P to the power
p
n.
power n.
And you are saying this is not correct.
Yes.
Okay. So how you will answer this kind of question if this is not correct? You have given a number, how you will say that there is a field of this size or not?
There is a field.
If this is not true, then how you will answer this kind of question?
There is a field of order. So this approach will not work.
Okay, let me give you a polynomial. Okay, this is the polynomial x square plus 1. 1 plus 1 will be 2, and okay, that is 0 in this field. Okay, so let me modify this polynomial. X square, I just want to give you a 2-degree polynomial. X square plus x plus 1. What will be its root? At 0 it will be 1, at 1 it will be 1, right? So it belongs to z2x, this polynomial. So check that. Okay, I give you a field of size 4. I am giving you a field of size 4 because you told that this statement is not correct. You cannot give a field of size 4. So I am giving you a field of size 4. So take this polynomial fx in z2x and claim fx is irreducible. How you will say this is irreducible?
Because in Z2 we have only 2 elements, 0 and 1.
And they are not root of this polynomial, right?
Yes, both are not satisfying.
Yeah, so we are done.
Yes.
So it is so it is irreducible, and z2 is a field, right? Z2 means Z2 means Z mod
Hello,
2Z.
sir.
Yeah.
Sir, this irreducible condition, can you again say?
Okay. So see, the polynomial is fx is equals to x square plus x plus 1. Right? So
Yes, sir, right.
yeah. So now if this polynomial is reducible, then the factors are only 1 degree, linear factor, right?
Yes, sir.
So now see, so if linear factor, that means it has a root either 0 or 1, since Z2 has only 2 elements, 0 and 1. So we see that neither 0 nor 1 is a root of this polynomial. If you put, what is f0? Let me write. What is f0? 0
One.
plus 0 plus 0, sorry, plus 1, which is 1, does not equals to 0, right? So this implies 0 is not root of f. 0 is not root of f. Similarly, f1 is equals to 1 square plus 1 plus 1, which is 1 plus 1 plus 1, which is 1. This is mod 2. This is 1 mod 2. Yeah. So this is the thing. So neither 0 nor 1 has a root. So that means this cannot be factorized as a linear factor. So it is not reducible. So it is irreducible. So now see what's going on. Since Z mod 2Z is filled, this implies Z mod 2ZX is PID, right? Agreed or not?
Yes, sir.
Yeah, if f is a field, then fx is a PID. So if this is a PID, then every irreducible polynomial will generate a maximal ideal, right? This I proved in my previous interaction session, maybe 4th interaction session. And this is also done in your class. So ideal generated by irreducible element is maximal, done in 4th interaction session, right? So now see this field action, this field Z mod 2Z x modulo fx. So Muthukumar, tell me, what is the size of this field? Will this be a field?
Yes, this is a field.
Yeah, this is a field because
And
because ideal generated by this is a maximal ideal, so this is a field. And what will be its size?
since f of x is of degree 2,
Yeah, so extension will be degree 2, right? So let's name this field as k. So k over Z mod 2Z will be 2. So that means k is a vector space of dimension 2 over Z mod 2Z. This means, what is this notation means? K is a vector space of dimension 2 over Z mod 2Z. Okay. So what is the size of a vector space of finite dimension over a finite field? Just recall your linear algebra. What is the size of a vector space? Because these are just the element in that vector space, right?
Sir, the linearly independent element there.
What is the size? Suppose V is a vector space of finite dimension over a field of finite
Sir, the
cardinality.
number of generator or
Number of element in vector space.
okay.
So what is, how many number of element in vector space, Muthukumar?
2 squared, 2 power n.
Yeah.
2 power n.
Yeah. So yeah. So number of element in vector space K over Z mod 2Z is equals to cardinality of Z mod 2Z to the power dimension of K, which is 2 to the power 2, which is 4. So agreed, Muthukumar, I gave you a field of size 4.
Yes.
So now tell me, is the statement you are saying incorrect? Is this true or not? So I gave you is like for I asked you for cardinality, and I gave you example of a field of size 4. Can you now see something that is this true?
So that means
Is this true or not? First, uh, justify yourself that is this true or not? How you will argue such kind of statement?
so that means whether it is possible to express in the form p power n,
Yeah.
whether the 1729 can be
Yeah, if
expressed
you
as-
prove this statement, then we are done, because then you can use this statement. If for every prime p and every natural number n there exists a field of size p to the power n, then you can just use this its factorization and can say yeah, either exist or not by using its factorization, either it is a prime power or not. But first you have to think about this statement. Is this true or not? If yes,
so this, for every prime p and any natural number n, you mean there exists a field, right,
yeah,
of size p power n.
yeah.
So my statement no is false.
Why? Give me a proof if you are saying this is false.
Okay, because I thought that Z4 consisting of 4 elements.
Yeah, Z4 is not filled, but I gave you a field of size 4. Now you can ask me similar question of 2Q, which is 8. So how I will give you a polynomial? What is the polynomial? What degree polynomial I need? You should now have enough intuition because I gave you an example. So let me ask you, give me a field of size 8.
Size?
8.
Size 8.
Yeah, which is 2Q.
So, size 8, you have to take a third degree polynomial, irreducible polynomial over.
So give me.
Is it 2?
Yeah, give me.
Sir, x cube plus x square plus x plus 1.
Okay, someone is giving a field polynomial. Sorry. So what is your polynomial? X cube
Plus x square plus x plus 1.
Okay. So is this irreducible? It has 1 as a root, right? So it is not irreducible. Not irreducible. Think something else. But you are in right track. You need 3 degree polynomial because the field is of size 2. So you wanted vector space of dimension 8. So think something else, but you are in right direction. Give me a irreducible polynomial of degree 3 in Z2 X.
That is 0 and 1 are not roots, right?
Yeah, yeah.
X squared plus 1 has 1 as a root. X cubed plus 1.
Tell me. You just need to give me a 3 degree reducible polynomial. That should not be that much hard. Just modify your example, whatever you give.
X cubed plus x plus 1.
Yeah, that's what I want to hear from you. You should remove just one term and this will work, right? So take fx is equals to x cube plus x plus 1. Now see, 0 is not a root of this one and 1 is also not root of this polynomial. So you are in nice case. So this is irreducible. Okay, this is irreducible. So now by same argument, Z2X quotiented by this ideal generated by this irreducible polynomial fx, this will be maximal ideal. So this will be a field isomorphic to field which is K. So this is field K. Now what is the size of this field? The degree of extension is degree of irreducible polynomial. So K over Z2 is of degree 3 because this is 3-degree extension. So this means, what this means, K is a vector space of dimension 3 over Z2, right? So this means size of K equals to 2 to the power 3, which is 8. So we are done. So I gave you a field of size 8 also. So now what? How you will generalize this statement? I gave you 2 square 2 cube. Now you can give similar idea for 2 to the power 4, 2 to the power 5, so on, so on. But how you will generalize this kind of statement for any prime P and for any natural number n? Tell me. Ravi Shankar, are you getting what I am doing here?
Yes, sir. Any finite dimensional vector space we can represent in the form of P power n, where P is a prime and n is natural.
No. So the question is this. The Muthukumar say to this question, answer is no, because we are solving the first part A part of this first question. There is a field of order 1729. We want to know is this exist or not. So Muthukumar told a statement, every finite field is of order P to the power n. So now then I ask him converse, that is for every prime P and natural number n, does there exist a field of size P to the power n? He says no. But I gave him example for 2 square and 2 cube. And it seems that this can be generalized. So how you will generalize it? I want to hear from you.
Now the question is whether the 1729 can be expressed as a natural number power
Yeah,
of a
question is
prime
this.
number. So you have to write
Yeah,
the
that is fine. But first convince yourself that is the answer to the question you say no. Is this true? Yes or no?
yes. Now the no should
Whatever
be
you said.
replaced with the yes. So
Okay,
straight
it
out
should be
no and
replaced by
write
yes.
yes.
Okay. 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 So that's fine. But how you will prove it? This is true.
So 1729 we have to split into prime
Leave
factors.
this 1729. Leave this 1729. How will you prove this question? For I just gave you 2 square and 2 cube. Now you are saying it is correct. But how you will give a proof for such kind of statement? For any degree, how you will give me a irreducible polynomial of that degree over any field with ZP? Tell me.
For you. So we need to find an irreducible polynomial, right?
Like for degree 2 or 3, it is fine. But for degree 4, roots are not necessary, right? You know, because for degree 4, there can be factorization of degree 2 also. So it is possible that there may not exist root, but they are reducible polynomial. So it is difficult to say from degree 4 onwards that polynomial is reducible or not. So how you will give me a field?
Sir, every prime order field we can do in that.
How you will do? Tell me. Should give me some idea, then I will proceed. get some idea. So give me a field of size 9. 9 is 3 square. So how you will give me a field of size 9?
Size 9 means we have 3 squared.
Yeah.
So 3 squared means we have to start with Z2.
You have to start with
Z2.
not Z2. We have to start with Z3. Because if you start with Z2, then the size of the field will be only in power of 2. You need power in field of size 3 power. So you start with Z3.
Now here it is Z3.
Yeah. So start with a polynomial, irreducible polynomial over Z3x of degree 2. And then you are done. So this is the idea, but how you will generalize this fact? You need some thought in this direction. Tell me how you will generalize. Can you give me a reducible polynomial of any degree n over a finite field? Is this easy or hard? Giving a irreducible polynomial of any degree n.
Any degree, yeah.
Yeah.
X power n plus 1 something like that.
Okay. Muthukumar saying something x to the power n plus 1. So x power n plus 1. This need not be right. Let me give you example. X to the power 4 plus 1, suppose. What is its root? How you will claim that this is irreducible? How you will claim? This may be reducible, right?
Sir, we have that Eisenstein criteria.
Over what field Eisenstein criteria works? What is Eisenstein criteria? Tell me.
Sir, only over Q field it will work now.
So how you will make that to finite field? Can you make that for finite field?
No.
Muthukumar, what he is saying is correct or not? Can you use Eisenstein criteria here for reducibility? Whatever you claim.
Irreducible, say Einstein criterion says if there is a prime number p that divides the highest.
But Eisenstein
coefficient.
criteria is only for over polynomial over Qx. This is over finite field. So how
Yes.
you can use Eisenstein criteria?
Okay.
So how you will say this is irreducible? Okay. So in general, it is not easy to check some polynomial is reducible or irreducible. So you have to do some alternate ways to prove this kind of statements. So how we will prove? This is done in your class. Have you read your lecture notes? This is done in your class in the section structure theorem for finite fields, something like that.
I think that may be in the eighth lesson.
Yeah, 8th week lectures.
8th lesson, not 8 studied. Only up to 7 they have posted.
Okay, fine, whatever. So this says the statement is true. The statement is true.
But the existence is
Statement is true.
guaranteed. There exists a
Yeah. This is, both are true. This one is also true. Every finite field is of order q to the power n for some prime p and some natural number n. Number n, and this is also true. This is true that for every prime p and for any natural number n, there exists a field of size q to the power n. What is the idea? Let me give you. So what is the idea? I will just give you idea. You can
whether this 1729
So,
can be expressed as p power n form.
okay, that we will do later. But let's first think about this one statement. How you will give me a field of size p to the power n for any prime p and any natural number n. So idea is this: take polynomial x to the power p to the power n minus x, which say fx belongs to qx. This polynomial is in qx. Agreed or not?
Yes.
Obviously
Square
agreed.
is 1 and minus 1.
So what? Yeah. So we can take its splitting field. There will be some splitting field for this polynomial, right? Do you know splitting field?
No, not yet. Splitting
Okay, let me
field may
explain.
be in lesson number 8.
KB splitting field of f.
This assignment is
Splitting
from 7 or 8.
eighth week practice assignment.
Eighth one.
Yeah.
For 8th one, they have not yet, I think, posted these video lectures. Up to 7 only we have received it so far.
So whatever you don't know, you can ask me.
Sir, in a splitting field, if there is an extension of a field, and we can express that as a product of linear factor in that extension.
Yeah, exactly. That is the way. Let me make it precise. So whatever you are saying is correct. So splitting field means field where the all, suppose take this. Okay, let me give you fx is equals to x cube minus 2. So what are its roots? What are its roots? Tell me. 2 to the power 1 by 3, omega 2 to the power 1 by 3,
omega squared
2 to the power 1 by 3, right? So now see this field q adjoined with 2 to the power 1 by 3. Is this, let me ask you, is this splitting field for, I will give you two examples. One is a splitting field, one is not. Is this a splitting field of f over q? And second one is gx is equals to x square minus 2. Its root is, what are its root? 2 to the power 1 by 2, comma, minus 2 to the power 1 by 2. Is q root 2 is splitting field for g over q. I have gave you two examples. Splitting field is a field extension. Suppose these are two polynomials in qx, right? So this is in qx and this one also in QX. So I am asking that splitting field for a polynomial is a field least matlab, minimum field extension such that it splits as a linear factorization in that. Are you getting the definition? I will tell you more precisely, but this is the intuitive way. Least degree field, least degree field extension in which it splits as a linear factors. The polynomial can be written as a product of linear factors.
X minus root 2 into x plus root 2. But those two factors are not in Q of x.
So what you are saying, can you say again?
X squared minus 2
Huh?
can be written as x plus root 2 into x minus root 2.
Right.
But those two linear factors are not over Q.
But I am asking, is Q root 2, right? Over Q root 2 they are.
Over Q root 2.
Yeah. I am asking, is Q root 2 splitting field for G over Q, right?
Okay. Yes, because it can be expressed as a linear factor with coefficients in Q root 2.
Yeah. So you gave a justification. Yeah. This is yes. And Muthukumar gave a justification. So what about this? What about this? I will write a definition of a splitting field for you here. Let me write because it will be more clear than for you. Okay. So let up to before when I was writing this definition, think about this example. I will ask you, is this true or not? Is this a splitting field or not? So let me write this definition. Let F be a field if fx is a polynomial in fx and fx belongs to fx a polynomial. The extension field then the extension field K of f is K of f is called splitting field for the polynomial polynomial f if fx factors completely into linear factors in kx. If fx factors linear factors in kx and does not factor completely into linear factors over any proper subfield of K containing Okay, so this is the definition, and this is just because Muthukumar justified this one, because you can write gx as a x plus root 2 and x minus root 2, this product, and this is a polynomial in root 2x. So you can do this. So what about, okay, so what about first one? Is this a splitting field for f over q or not? Can you write it as a linear factors here in q2 to the power 1 by 3?
Omega 2 power 1 by 3 and omega square 2 power 1 by 3 are not members of q of 2 power 1 by 3.
Okay, that's why omega 2 to the power 1 by 3 is not member of q2 to the power 1 by 3.
Omega is a complex number,
Okay,
and
so
q of 2 power 1 by 3 is the smallest field containing q and 2 power 1 by 3.
so it is contained in R. So omega is a complex number, so it cannot be in that field, right? q2 to the power 1 by 3 is contained in R. So omega
Yes.
is a complex number, so it cannot be there. So that's why this is. So this is
So sir, 2 power 1 by 3 can be, no?
2 to the power 2 power 1 by 3 can be, but you cannot write as a linear factor, right? You can write as a linear factor and a 2-degree factor. You can write is this as this one. Okay, let me write here. You can write this as x minus 2 to the power 1 by 3 into x square plus x plus something like, I don't know exactly what will be the polynomial, but some polynomial gx. You can calculate what is the gx. This will be a degree 2 polynomial. And you cannot factorize it as a linear factor because these two roots are not there. Its root will be these two roots. This have these two as a roots. Agreed or not?
Yes, sir, agreed.
Yeah, so that's why it is not splitting. Okay, so what we are doing, so x to the power p to the, okay, I am giving you idea. So I gave you this polynomial in qx, and I am saying let k be splitting field for f over q. So you, for any polynomial over qx or over any field, you can find a splitting field for that polynomial. That will be done in your class. Okay, so existence of the splitting field will be done in your class. So you can assume that there exists some field where any polynomial factorized as a completely linear factor, because intuitively it is clear, like over q, any field, any polynomial over q will have root at least in C. So you are done. You just, so at least C will be splitting field, but there can be some smaller than that. But in C you can always get linear factors. So splitting field always exists. So this should be not that much tough statement. It should be, at least intuitively it is easy. So you can assume this one and it will be done in your class. So let k be splitting field of f over q. So what is my idea? Idea is this. What's happening? Okay. So my idea is this. So I gave you this polynomial fx is equals to x to the power p to the power n minus x. This polynomial. So idea is this: collect its all roots. Collect its all roots and claim that this forms a field of size p to the power n. So this is the idea. So are you getting something or not? Muthukumar,
Yes.
you are getting or not?
All roots.
All roots of this polynomial x to the power p minus n, pn minus x, and claim that this forms a field of size q to the power n. So what is the first question in your mind? Ask me. What is the first question? What can be the first question in mind when I told this statement? This is a p to the power n degree polynomial, and I write that this field should be size of p to the power n. But why? Its root should, I am saying that it should have p to the power n roots. But the first question should be why they all are distinct, because you are claiming that its size is p to the power n. So how you will justify that its all roots are distinct? Tell me.
Sir,
You are
with
getting or not?
P is prime here now.
Yeah.
So the roots which we'll get will be distinct.
Why we will get distinct roots? P is prime, so what? Are you getting what I want to say you? I am saying that I gave you a polynomial x to the power p to the power n minus x. In Qx, I am saying that collect its all roots and this will form a field of size p to the power n. The first question is why it should have p to the power n distinct roots, because I am claiming the field should be size of p to the power n. So have you read separability, separable polynomial and these things? Madhu Kumar, have you read this? At least say yes or no.
That is, you can find a field of size p power n, right?
Yeah. So I am saying that why it should have p to the power n distinct roots. There can be possibility that two roots are same. If two roots are same, the size will be decreased, right? So I am
How
asking you why these
okay,
roots.
you can differentiate once and see whether is there any common
Yeah,
root between.
that's what I want to hear from you. But you are not even saying anything. How I will understand you are getting or not? So now what? So now what? This is the one-time differential. So what?
You have to say there is no common root between f of x and f dash of x, right?
Yeah. Let's say this polynomial in ZPX. So,
Sir, when it is non-zero, we will get simple root. When f dash x is a non-zero.
this is in ZPX, right? So what? This term is 0. This is
Three
minus 1.
times.
So any root here is not root of this one, right? Agreed or not?
Yes.
Because so they does not have common roots. So that implies all roots are distinct.
Sir, why did we use here this differentiation? Like, what was the need of this?
How you check separability? Fx and f dash x should not have a common root, right? So that's how you can check separability. So this is the way to check separability. So all roots are distinct. So at least its size is p to the power n, but you can check that this forms a field. If alpha p to the, okay, how you will check it is field? Suppose alpha and beta are root of this. That means alpha p to the power n minus alpha equals to 0. That means alpha p to the power n equals to alpha. Beta p to the power n equals to beta. So this implies alpha beta p to the power n is equals to alpha beta, right? So this is also a root. So if alpha non-zero, then you want to say 1 upon alpha is also a root, right? So you want to say 1 upon alpha is also a root. Also root. So for that, what you need to show? 1 upon alpha p to the power n is equals to 1 upon alpha. So that is precisely you need to say alpha is equals to alpha p to the power n. But that is given by polynomial condition. So you are done. Alpha inverse is also there for non-zero alpha. What else you need to check? 0 is also root, because 0 is also root, because 0 p to the power n is equals to 0. 1 is also root. 1 p to the power n is equals to 1, right? And what you need to check? Closure under addition, right? How you will check? Alpha plus beta. If two are alpha and beta are two roots, you need to check alpha plus beta p to the power n is also a root. If alpha and beta are roots, then alpha plus beta also root. You need to check this one. How you will check this one? You need to show alpha plus beta p to the power n is equals to alpha plus beta. Muthukumar, is this true or not?
It's true.
How?
So you have alpha raised to the power p power n.
We have alpha and beta are roots of this one, x to the power pn minus x is equals to 0. So you are saying alpha plus beta also root of this one. So we need to show alpha plus beta p to the power n minus alpha plus beta is 0. So that is this one. So how you will show this one? Alpha plus beta p to the power n. How you will open this by binomial theorem? N choose 0. N choose 0. Alpha to the power n plus n choose 1 alpha to the power n minus 1 beta sorry, p to the power n, right? It has a p to the power n, to the power n, write everything in terms of p to the power n minus 1 plus so on plus p to the power n choose p to the power n beta p to the power n. So what is the idea? You need to show that what is this one?
We are in ZP.
Yeah. What is p to the power n choose 0? What is n choose 0?
1.
1, right? So this
Yes,
is
sir.
1.
So
This is 1. This is 1. We need to show that all these terms are 0. In middle terms are 0. Then we are done, right? Because alpha p2, this will be, then it is same as alpha p to the power n plus beta p to the power n. But alpha is the root of that one. That means alpha p to the power n is alpha and beta p to the power n is beta. This is same as alpha plus beta. Since alpha and beta are root of x to the power p to the power n minus x is equals to 0. So now how this will be? How all terms will be 0? How you can say something in 0 in ZP? Because these are all in ZP, finite field ZP. It should be some multiple of P, right?
A multiple of P.
Yeah, it is multiple of P. You can see. All coefficients are multiple of P. So it is a check exercise to check you. check that all these coefficients are multiple of B. So yeah, we are done. So this is field. So this means we have proved that not proved, but intuitively at least we proved that s to the power p to the power n minus x roots forms a field of size p to the power n, size p to the power n into zpx. Yeah, so we are done. So is this idea clear to you or not? At least you should get some intuition. Proof you can see again, but intuition you should get how we are doing. So Muthu Kumar, is this clear?
Yes. Clear.
And Ravi, is this clear?
Oh, yes, sir.
Okay. So at least you should get some intuition. Now come to this first part, whatever we are doing. So there is a field of order 1729. Is this true or false?
Sir, 43 square, I got 1849. So
Not 43 square. So can you write it as a prime power? So question is,
like 43 is a prime and 2 also I can say. So, but it is not.
yes, so think about some different prime powers, right? First do its prime factorization. What is its factorization? Tell me its factorization. What is its factorization? Tell me. Do its prime factorization.
Yes, sir. Sir, with 7 it will go.
Yeah.
So 7 is.
Sir, with 7 it will divide 7.
7. 7 when you're 7, 7 to the 14.
Yes, sir. 7247.
7 into
7 into
247.
7 into 247.
7 into 247. Now this one 247 is this prime 247? No, I think no.
19 is another factor.
Sir, with 13 it will divide 247.
So what is its prime factorization? Give me prime factorization. You should do
7
it.
into 13 into 19.
219. Yes, sir. 7, 13, 19.
7 into 13
into 19.
Yeah. So can you write it as some prime power?
7 power 1, 13 power 1, 19 power 1.
No,
Cannot
single prime power.
Not possible.
Why? Is your factorization correct?
Yes, 7, 13, 19, they all of them are prime numbers, distinct prime numbers.
Is your
So
factorization correct?
any number can be expressed in a unique way as a product of primes.
But just check your factorization is correct or not. Let me check this by calculator because it seems that this is factorization is not correct. Let me check. Yeah, it is correct. So yeah, it is not true, right? So there is no field of order 1729 because it is not a prime power, right?
Yes, sir.
So this is false statement. Where is this? False. So next part. Okay. The question is 729. Question is not 1729. So now tell me about 729. Let me write.
729 is the 9 cubed.
9 cube.
Yes, that is 3 power 6.
Of
Yes,
size.
sir. It is 9 cube, sir.
Yeah. Okay. Which is 9
Or
cube. So it is true. 9 cube is 9 cube is what?
3 power 6.
3 square to the power 3, which is 3 to the power 6. So this is true, right? So now the B part. B part. There is a field of order 2190. Tell me, is this correct or not? What is its prime factorization?
Because 3 and 2 are factors.
Yeah.
Therefore, you cannot express as a prime
2
raised
2
to the
into
power
3
n
into
form.
573
2 into 3
into 5 into 73.
5,
Is this-
how 5 will come?
5 can come, right?
Yes, sir. It will come.
2190.
Yeah. Let me check, is this correct or not? 2 into 3 into 5 into
730.
Yeah, it is correct. So it is not a prime power, right? 73 is prime.
Because when you have both 3 and 2 are factors,
Yeah,
then
yeah.
you cannot have prime
Yeah,
power.
you cannot have prime power, but I am just wondering, is 73 prime or not? Yeah, it should be right. 73 is prime number, I guess. Yeah, it may be. Yeah, it is. Yeah, so this is the prime factorization, but so not of the form p to the power n. So this means there does not exist any field.
Sir, if 2 and 3 is there in the product, so can we directly say that there won't be any?
Yeah. Any, if there exists any field of size, if there is any field of finite field, then its size must be of p to the power n for some time p and natural number n. P got. There is a field of order 510.
This is a D or C.
C. 510.
510.
Yeah. Is this how you will write this one?
Yeah. Yes, sir. It is 2, 3, 5 into 17.
So this means this is, there does not exist any field of order. So this is
Yes.
also false. So this is also false. I hope your factorization is correct. I am not doing this. Check that this is correct or not. And the last option is saying there is a field of order 2048. Do its prime factorization. 2048.
It can be expressed as 2 power some integer.
How you will argue? Give me its
Sir,
factorization.
it is 2 power 1024 into 2. 2 power 10.
2
So
power 11.
11. 2 power 11.
Okay, so they are saying 2 power 11. I will just write, but yeah, it is. So that means it is field. This implies there exists field, such field. So it is true. Wait a second.
Excuse me, before you go to second problem, I have doubt.
Okay. Let's do second problem. This is clear, right?
Okay, excuse me, I have a doubt in
Yeah.
that primitive pth roots,
Yeah.
where p is a prime number.
Yeah. Yeah. Tell me.
That they say the primitive pth root is e power 2 pi by p.
Okay, that I will tell you. That I will tell you in third question. Maybe third
Okay.
question on next assignment. Whatever I will do, because this question I have done, I will do with you. Primitive root means its generator. Like this forms a cyclic group. Nth root of unity forms a cyclic group. So generator of this cyclic group are called primitive nth root of unity. So that I will do. So the basically you are saying that 2 pi I by n and 2 pi I k I by n, where k is
Yes.
coprime to n, these are primitive nth root of unity, where k is coprime to n. This is precisely the statement that in Zn, in cyclic group Zn, the numbers which are coprime to n are generator of this cyclic group Zn. This is analog that statement. Even they are same because these two groups are isomorphic. Nth root of
Relatively prime numbers.
yeah.
Suppose if p is a prime number, then all number except 1 less than p are relatively prime.
Yeah. So they are generator of this one.
So therefore, all of them are
Generators.
primitive
Yeah.
pth roots.
Yeah.
Suppose if you want to say that primitive fifth root is not a member of Q of primitive seventh root.
Yeah.
Primitive
Fifth root is not a member of primitive seventh root. So like x to the power 5 minus 1 have different primitive root than x to the power 7 minus 1. That you need to show. And that is almost obvious. Not almost obvious, but that is easy observation. You can just argue by group. Like x to the power 5 minus 1 have 5 roots. So it's
Please kindly write that one. This
yeah.
e power 2 pi I by p.
Yeah.
E power 2 pi I by p.
Yeah.
Not a member of
Q
of e power 2 pi I. So the p can be changed to 5. P can be changed to 5.
P can be changed into 5. Okay.
5. This first prime p is 5. Q of e power 2 pi I by 7.
Okay. So this is easy, right? So see, this is the root of the polynomial. What this is the primitive root of the polynomial. Primitive root of the polynomial x to the power 5 minus 1 equals.
Yes.
And this is the root of x to the power 7 minus 1 equals 0, right?
Yes.
So its root will be form a cyclic group. So the field you are saying its root will form
Cyclic group generated by the 2 pi I by 5.
Yeah, means generated by 2 pi by 5, that is of order 5, right?
Yes.
Yeah. And it will be form a multiplicative cyclic group, root non-zero roots. Yeah, 0 will be not root of this. So form a multiplicative.
Roots, all of them are non-zero only. Multiplicative cyclic group.
Yeah. So this is 5. And here, so okay. So its size is 7, its size is 5. So when is subgroup possible order of a subgroup of a group? This argument you can use here.
So you mean to say member means
it has a four primitive root of unity, right? It has a 4 primitive root of unity, and it has a 6 primitive root of unity. And I will tell you these facts. Means I
Okay,
will
6 primitive roots of.
you 6 primitive root of unity. This one have.
That means the roots are same. You mean to say only the number is different.
Okay. K star. Okay. 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 So basically idea is this forms a multiplicative group, cyclic group of order 5. This forms a multiplicative cyclic group of order 7, right?
Yes.
So now you are saying this does not have a common, what you want to say, this does not have a common member, right?
Yes, this is not a member of that one.
So how you will argue? So what are the possible order of this element? This group, its order is either 1 or 7. Its element order is either 1 or 5. So they are not, cannot be same, right?
This element is
Only one can be both. One can be in both places, but one is not a primitive root. You are asking about primitive root. Agreed or not?
it is these fifth roots of 1 and seventh roots of 1, they are entirely different.
Yeah,
Are they
they
not?
are entirely different, except their primitive roots are different. One is not
Yes,
different. One is both.
one is because we will not consider one. So
Yeah. Yeah, because all other elements are here of order 7 and here are of order 5, right?
well, is there any, if it belongs to that member, is there any connection between P and Q?
Yeah. What you can think? Okay, think about this kind of scenario. What kind of times you can think? But not simply prime, but think about some prime power. Suppose this is 5. This is where you write 7. Take as a 5 square.
Say I take 11.
Then it is not. For primes it will not, but prime powers it will work, right?
Oh, 5 and 5 power.
Suppose 5 power 2, 5 power, you take something. Suppose take 5 power 2 and 5 power 3. Then it will same in this, as in this case. But you take like 5 and 5 square, then it will work, whatever you are saying.
Here 2 pi by 5, P is 5 means Q must be power of 5.
Yeah,
That's
so
what-
that a more general statement is that this is your 7th assignment question. So I will do it there because I will do that assignment also with you. So it is that assignment question, previous year 7th assignment question. Because some other student also asked me this question, so I explained you. So I will do it there. Don't worry. So, but this is the idea. I hope your intuition is clear to you.
Because these concepts not being dealt in 7th lesson.
Okay. So maybe this is not done in your course, but you can refer Damit Food. Damit Food. This, there it is done clearly. Let me tell you page number. Damit Food page number. This one page number is 539.
In which one? In which book? 539.
Yeah, abstract algebra by Damit and Food.
Pardon?
Damit and Food abstract algebra book. Abstract algebra by Damit and Food. 52 page number 5
Algebra by
Damit and Food. Damit and Food.
Please kindly write that author name. Algebra
Okay, let me
by-
show you my screen. I will show you that book.
Okay, okay.
If I can say, okay, abstract algebra by Damit and Food. You can see my Chrome page, right?
Oh, sir, your presentation page is there.
Not visible.
Okay, let me show you. Okay. Where I will do this one screen share. Yeah, right. Share screen. Yeah, abstract algebra. Yeah. Yeah. Can you see this one? Abstract algebra, third edition, Damit Food book.
Abstract algebra.
This is the book.
Abstract algebra.
What he's saying. This too. Maybe it will not download, but yeah. Download PDF. If it is possible, let me show you. But this is the book. Yeah, book is going to download, but it is 33 MB. It will take some time. So, yeah.
What is the author number? Abstract algebra, third edition.
By Damit Food.
Where is the author name there? Demitro.
Yeah, this is Damit and
David S. Dumit.
you can write Damit and Foote. You will get. This is famous book, standard book. Yeah, so this is downloaded. So let me show you. This is the book. This is the book. This is the David S. Damit and Richard M. Foote. So there is a 539 page. There you can see this all these concepts. 439, sorry, 439. It is not working. So it is not working basically, but you can see. This is the book.
Okay, I will try.
Yeah. So now let's do next question. And I will do basically this thing maybe in next class or maybe in this class if time permits, because this is the part of 7th assignment. You can look over previous year's 7th assignment. This is there. Have you done that?
Not yet. The date is there.
Okay.
Because this concept has not been dealt with in the lecture.
Okay. Yeah, but I will do this in my course interaction session at least. I will do this in detail. Maybe this one or maybe next. So don't worry. So yeah, so let's do second part. Okay. F to the power 24 be the field of F to the power 24 be the field of order to the power 24. How many subfield does F to the power 24 contain? Subfield does F to the power 20 contain, including so the options are 6, B is 7, C is 8, and D is 9. So tell me, what are the subfields? how many subfields of f2 to the power 24? Basically 2 to the power 24 are what? You can think of this as a root of this polynomial, x to the power 2 to the power 24 minus x is equals to 0. So what are basically it's a subfield. Subfield means what are all possible powers of 2? 2 to the power k equals x to the power 2 to the power k minus x. Are you getting what we have to do? See,
The field containing such a big
if alpha
Root of-
belongs to f2 to the power 24, this implies that alpha 2 to the power 24 is equals to alpha, right? Because this is the field collection of all these kind of terms, roots.
that is the non-zero elements form a
Yeah.
group.
Yeah,
So therefore, alpha raised to the power that order of the group 2 power 29 minus 1 is 1. So
Yeah.
you are getting this equation. Okay.
okay.
So alpha,
Sir, it should be 9, like
No, it should be 4.
4.
Yeah, 2 to the power 24.
No, no, matlab, in option 6, 7, 8, 9 is there, no?
Yeah,
24 we can write like 2 power 3 into 3.
24 you can, okay, sorry. 24 you can write is as
2 power 3 into 3.
2 power 3 into 3. 2 दूना 4 दूना 8 3 24. Okay, correct. So what?
So 3 plus 1, 4 or या फिर
So what are the possible field? Subfield. So here is your f2 to the power 24. What are its possible subfield? One possibility is f2 to the power what? 2 to the power 3 means 2 to the power 8. Other possibility is what? How you can write this as a different terms? 2 square dot 3, 4 dot 3, 2 to the power 12. F 2 to the power 12. What else? How you can write this as more ways? F 2 to the 2, 3 to 6, that will be there. F 2 to the 6 and what? F2 to, okay, F2 to 4 and what? F2 3 F2 2. Is there anything else? Is there anything else possible? Tell me. Are you getting what I want to do? See, we want to collect subfield, right? We want to collect subfield. So if alpha is a member of this f2 to the power 24, that means alpha satisfies this equation. So we want to collect subfield. So what are subfield? That should be right. That should be root of form some f2 to the power k. But what of the form 2 to the power k? What kind of subfield you can construct? Only kind of element where k divides this 24, right? Otherwise, you will not get such root there. Such polynomials root x to the power k minus x is equals to 0. You want to get its all roots if you want to get f2 to the power k field. So that is only possible when k divides 24. So I just want to include all such possibilities of k divides 24. So he gave me a factorization. I give you all possible with like 8 divide 24, 12 divide 24, 4 divide 8 and 8 divide 24, 6 divide 12 and 12 divide 24, 3 divide 6, 6 and 2 divides 4 and 2 divides 6. So this is the all possible, right? Is there anything else? Okay. Yeah, f 2 to the power 1, right? This is also something. F2 to the power 1. And this is also a subfield of this one. Yeah. So this is the diagram, right? Are you getting or not? Muthukumar, are you getting or not?
Yes.
So how many subfields you get? 1,
8.
2, 8 get. Yeah, 8 subfields. This implies there are 2 subfields of f to the power 20. So yeah. So now next question is, choose your correct statement. The question is, so tell me, is this true or not? You know splitting field, you know degree of a field extension. So tell me, is this statement is true or not? What is the degree of field extension?
Sir, it is the dimension.
It's easy. Over Q, we can factorize it as x squared plus 1 into x squared minus 1.
Yeah. So
And x plus 1 into x minus 1, x squared plus 1.
x minus 1, x squared plus 1. So what are the roots?
1 minus 1, I minus I.
I minus I. So what is the splitting field? What is the splitting field for this? Tell me, what is the splitting field? Over Q of this polynomial.
Q of I.
Q of
I.
Q iota. Yeah. And what is its degree of extension?
Two.
So how you will say that Q iota is splitting field? Tell me how you will say Q iota is splitting field. You know definition of splitting field, right?
The smallest extension containing all roots.
Yeah, here is the definition. Here I write. This is the definition. First read the definition. You read it, right?
Yes.
So now tell me. Now tell me why it is smallest. It completely splits in linear factor in 2 iota. It is clear, right? It is clear, right?
Yes.
It
In
splits as a
QI, we can factor
Yeah.
into linear factors.
Yeah. So why it is the smallest? How you will argue? Because Q iota is the smallest field containing iota, and iota is its root, right?
So that must be of degree 1.
Yeah. What you are saying? I am saying that iota is the root of this polynomial fx. So if there is any field, subfield of 2 iota, which contain in which f splits as a linear factor, that means iota is there in that field, right? But Q iota is the smallest field containing iota or and Q. So that means that field is Q iota. Agreed or not?
ZI. You mean ZI?
Splitting field. Let me justify. For fx is Q iota. It is clear that fx splits into linear factors in Q iota, right? So now only need to show Q iota does not have any proper subfield containing Q, but containing Q, right? In which f splits. Since Q iota over Q is extension of degree 2, if there exists a proper subfield K, proper subfield of Q iota, then Q iota over Q extension degree is strictly greater than, not equals, strictly greater than of K over Q. That means this is, since this is 2, this implies K over Q is must be 1. That means K is equals to Q, isomorphic Q. So this means F splits into linear factor in Q, which is contradiction. Which is contradiction. Agreed or not?
Agreed.
Yeah. So this is the justification. So Q iota is a splitting field, and this is the degree 2 extension. So do you know Euler-Toshan function? You know Euler-Torsion function?
But Euler's function phi of n.
Yeah.
If integers less than n are relatively prime to n. Positive.
Yeah. Try to connect that with this one. I will do a lot of example and try to connect that with this one. Degree of extension of a splitting field. So here is the part B. The degree of splitting field of x to the power 8 minus 1 over q is 4. The degree of splitting field of x to the power 8 minus 1 over 4. Tell me, is this true or not? How you will do? How you can write x to the power 8 minus 1? X to the power 4 minus 1, x to the power 4 plus 1. And this is what? X minus 1, x plus 1,
X square minus 1.
minus I would x square plus 1 and x to the power 4 plus 1. Now see, these terms are same as the previous one, and this is the new term. So tell me, what are its roots? Can you say its root?
E power I into 2k plus 1 pi. E power
E power
e raised I
Yeah.
I within bracket 2k plus 1 multiplied by pi, odd multiple of pi, where k equal to 0, 1, 2, 3.
Why this? Its root are this one, right? E to the power. Yeah, it is correct. X to the power 4 is equals to minus 1. What is minus 1? Minus 1 is equals to cos. It should be minus 1. Cos is minus 1 at yeah, it is correct. Right. It is correct. So these are roots. So what we want to say, it's a splitting field degree. So its root are all degree 4. It have a degree 4 root, right? What are its? E to the power 2k plus 1 pi. What are these? Cos 2k plus 1 pi plus I sin 2k plus 1 pi. So you can check what these values. So you will get there. So what is the degree of a splitting field? Tell me. Can you see this polynomial is irreducible polynomial x to the power 4 plus? Over q. Muthukumar, can you see this is irreducible over Q?
But
And Monica,
x power 4 plus 1.
over Q is irreducible.
Yes, it is irreducible.
Over Q. Why?
Because with the coefficients in Q, we cannot factorize it.
You cannot.
Because the roots are all complex numbers.
So what?
So it is irreducible.
Why?
You cannot reduce it further.
How?
Before
Why? How you will justify?
That equation x power 4 plus 1 equal to 0 has no roots in Q. X power 4 plus 1 has no roots in Q.
Okay. So no roots in Q. So if a polynomial will have no roots in Q, then it will be irreducible over there. Let me give you a polynomial x square plus 1 ka whole square. It will not have this polynomial fx. This will have no roots in Q, right? But it is irreducible. It is not irreducible, right? It is reducible. So how you will justify yourself? Tell me. See, this is the idea you have to use. X to the power 4 plus 1 is, if this is reducible, then you can write this as a product of two polynomials.
Yes.
Or two or more polynomials, fx or gx. So now argue on the degree of this polynomial fx and gx. If fx is have degree 1 term and gx have degree 2 term, then there is a polynomial, there is a term of degree 3. If this have so you can suppose it have a degree 2 term, it has also a degree 2 term, and since you have constant term here, you also need constant term in both constant term. So see, when you multiply with degree 2 term with constant term, you will get a degree 2 term, but that is not there. Similar idea, you can argue in this way that this is irreducible. Argue by degree argument that this polynomial x to the power 4 plus 1 is irreducible. Okay, so if this is irreducible, then what? Now you need to show, if you want to say that this is the 4th degree extension, so what you need to show that all these roots are also there in splitting field of this polynomial x to the power 4 plus 1, means 1 minus 1 will be obviously in Q. You only need to show iota is also there in that one. How you will show? Over see how you can write it. Right or not? I'm just giving you intuition. Muthukumar,
No.
is this clear or not?
Yes.
Over C you can write this as a x square plus iota, x square minus iota. See, you gave me this one root, right? These are the roots, right?
Yes.
So when you put k value, what? K value 1, suppose. what you will get? E to
K
the power,
value 1.
yeah. So you will get e to the power 2 plus 1, 3. So e to the power 3 I pi. So what is this?
Is minus 1.
Cos 3 I pi plus I sin 3 I pi.
No. 3 pi only, no I.
Yeah, sorry, no I. 3, yeah.
Cos 3 pi minus 1, that is 0. So you get
Yeah.
minus 1.
Yeah. But that means you did not write this one correct. There should be some iota here also. You will, if this is correct, then you will not get any iota term because sine is always 0. So this is not correct, whatever you written. 2k plus 1 pi. This is not correct. So what is this?
X power 4 equal to minus 1. Minus 1 means cos pi plus I sin pi.
X to the power 4 equals to minus 1. Minus 1 means?
Cos pi plus I sin pi.
Cos pi plus I sin pi, correct?
Which is same as cos 2k pi, 2k plus 1 pi.
Why it is same?
To get the general value, cos 2k plus 1 pi
2k plus 1
into pi.
Okay.
Plus I sin 2k plus 1 into pi.
But yeah, that is correct. But why it
So
seems
this is raised to the power 1 by 4.
Yeah.
That by 4 we have omitted there. That is the problem.
Yeah.
2k plus 1 pi by 4.
Yeah, that's what I am saying. There should be something like that. Yeah. So if that is there, then you are done, right? So if that is pi by 4 is there, when this is 2 pi by 4, for suppose 2 plus 1, 3 pi by 4, you will get iota there. I just want to show when the cos term is 0 and you will get some iota term there. When sine is non-zero basically in this expansion. 3 pi by 4. What is 3 pi by 4? Sine 3 pi by 4. Basically, you need to show that iota is also there in splitting field of. Okay, but you need to show.
Q of pi. In Q of pi, all roots are there.
Yeah. No. Q of I naught. Where is this one? I missed it. Oh, the screen is freeze.
Irrational number will also come into picture, right?
Let me write. So we need to show iota lies in a splitting field of x to the power 4 plus 1. We only need to show this, right? So what is the splitting field for this one? Its splitting field for this one is just q adjoined with fourth primitive root. I should not say fourth primitive root of unity. But yeah, what are its roots? What are its roots? Its roots are 2 e to the power iota 2k plus 1 pi by 4 you said, right? Let me check this, pi by 4 or pi by 2? Pi by 4. Pi by 4, sorry, yeah. Pi by 4. So yeah, so what are these? For k equals to 0, 1, 2, 3. So what for k equals to 0, what value you get? For k equals to 0, you will get
1 by root 2 plus I into 1 by root 2.
For k equals to 0, we will get e to the power iota pi by 4, which is cos pi by 4 plus
1 by root 2 plus I times 1 by root 2.
Plus I times 1 by root 2. For k equals to 1, you will get what
K
you will
equal
get?
to 1, we will get minus 1 by root 2 plus I by root 2.
I hope you are saying correct. I by
Root 2.
For k equals to 2, you what we will
This is
get?
also root 2. The above first one also root 2, not 2.
Okay. What is the third one? For k equals to 2?
Third one, if you go to
No,
k equal to 2, that is minus 1 by root 2 minus I by root 2.
Okay. And what is the fourth one?
Fourth one is 1 by root 2 minus I by root 2.
Okay, assume this is correct. So now you can see iota is there. Since how you will see iota is there? See, these if these two roots are, since these two roots are in there in splitting field, so their sum is also there. So now that means 2 iota by root 2 is there, right? Agreed or not?
Yes, that is root 2 I is there.
Root 2 iota is there, that means, right? You need to show iota is there. So how you will say root 2 iota is there, then how you will say iota is there?
So you should have Ri.
Yeah. This thing belongs to some field K, then you need to show that this 2 also belongs to K, right? How you say iota belongs to K? Tell me. If product of two elements in a some field, then is it possible that the element are not in field? Muthukumar, is this possible?
That I is in K is possible. You're asking?
Yeah. I am asking that is this possible that if product of two elements is in field and one of element is not in field?
In a field that is
Yeah, it is possible, right? Root 2 and root 2 in Q, but root 2 is not in Q. So it is possible. So how you will argue this is iota is in K? If iota does not belongs to K, if iota does not belongs to K, that means but root 2 iota belongs to K, that means what? That means what? Mm, root 2 iota dot root 2 iota belongs to K, that means root 2 iota dot root 2 iota is also in K, right? Belongs to K, but that is precisely -2. So we have to do something, more than that. Root 2 iota is in K and 1 by root 2 plus iota by root 2 in K. And root 2 iota is in K. This implies that iota plus, sorry, iota minus 1 is in K, belongs to K, right? Now see, iota minus 1 is in K and 1 is in K. 1 belongs to K and iota minus 1 is in K. So that means iota minus 1 plus 1 is in K. This means iota is in K. Is this clear?
Yes.
How we conclude? Since 1 by root 2 plus iota by root 2 is in K and root 2 iota is in K, so their product should be in K. So that means 1 by root 2 plus iota by root 2 into root 2 iota is in K. So that means their product means iota minus 1 should be in K and 1 is also in K. So that means iota should be in K. Agreed or not?
Yes.
So
Sum
that
is
means,
also in.
yeah, this means we prove.
सर iota minus 1 is कहाँ हमने निकाला है?
ये निकाला है भाई, ये निकाला है. 1 by root 2 plus iota by root 2 dot root 2 iota should be in K. So what is this product? 1, which is iota, means iota minus 1. Iota I square is minus 1, right? root 2 से root 2 कैंसिल हो जाएगा. पहले स्लॉट में आयोटा, दूसरे में आयोटा 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 डॉट आयोटा माइनस 1 हो जाएगा, राइट?
हाँ yes sir.
Yeah. So we proved that iota belongs to, iota is in splitting field of x to the power 4 plus 1. So only need to check splitting field of x to the power 4 plus 1. What is the degree of splitting field of x to the power 4 plus 1? We need to check only this much now. What is the degree of splitting field of x to the power 4 plus 1? So x to the power 4 plus 1 means x to the power 4 is equals to minus 1, right? What is the degree of splitting field they are asking for? So see, here we write this all roots. E to the power iota 2k plus 1 pi by 4. Now you can see the primitive root will generate if I adjoin the primitive root e to the power q e to the power iota 2 matlab 2k equals to 0. So e
power
iota
I pi by 4.
Yeah, so this will generate my whole splitting field, right? Because this is the primitive root of unity. All other roots are it's just power
Yes.
This, yeah, it's a square means. Suppose this is zeta. Suppose this is zeta. So other roots are zeta square, zeta cube only. Zeta square, zeta cube only. Yeah. So this one. So this is zeta. So yeah, means if zeta. Yeah, I should write this as zeta is equals to e to the power 2 pi by pi iota, sorry, e iota pi by 4. E I pi by 4. So other roots are it's just powers. It's a square and so on. So you can see that this field, this is splitting field. So you only need to check its degree of extension. But its degree of extension is 4 because this is the root of the x to the power 4 plus 1 and we check that this is monic irreducible minimal polynomial for this. So yeah. So degree of extension q iota pi by 4 over q is 4. So degree of extension of splitting field of x to the power 8 minus 1 equals to 0 is 4. So is this clear or not? Muthu Kumar, is this clear?
Yes.
Ravi, is this clear?
Yes sir.
Okay. So with this we will finish here, but I just want to comment that see, in case of x to the power 4 minus 1, we get the degree of a splitting field is 2. Is in this case, we get degree in case of x to the power 8 minus 1, the degree of splitting field is 4, which are same as C. Phi 4 is phi of 4. What is phi of 4? What is Euler-Thomson function of 4? 4 dot 1 by 2, which is 2. Similarly, phi 8. What is phi 8? 8 dot 1 by 2, which is 4. So you are getting the degree of splitting field is same as Euler-Thomson function. Degree of splitting field is equals to phi, and you are getting. And this is true statement. So the intuition is comes from these ideas, these truths, whatever we give. You should try to observe this statement. This is a standard statement. You will get its proof in Damit Food. But yeah, this is the observation you have to take from here. Are you getting or not?
Splitting field of the nth degree polynomial.
Yeah, nth degree.
Polynomials.
Yeah, nth root of unity means whatever the polynomial x to the power n minus 1. This splitting field is basically phi n degree. We prove in two cases. In case of n equals to 4 and n equals to 8. Okay. So with this, I will finish the session here. So if you have any doubt, you can say, or any suggestion you want to say, you can say to me. Otherwise, we can stop here.